Hi viewers, welcome to LMS Solution. Today we are going to see about off-grid solar PV battery system. So in this system, we can see that this is a simulation model for the off-grid solar PV battery system. The system consists of solar panel. The rating of solar panel is 2000 watts PV panel, and then the rating of panel, that means the single panel rating is 250 watts, and then voltage at maximum power point is 30.9 volt, and then current at the maximum power point is 8.1 amps. And here we are using 4 series model per string, and then we have 2 parallel string. Okay, and here you can see that the IV and PV characteristics of the solar PV panel. The peak power of solar PV panel or PV array going to be vary with the change in irradiation. When irradiation reduced, right, the peak power also going to be reduced. Okay, here we need to extract that maximum power or peak power of the solar PV array. So for that, here we are using MPPT algorithm, that means PSO MPPT plus battery charger controller, right? This solar PV output, okay, going to be connected to the single phase DC to AC conversion element. That means the output of solar PV directly is fed to the AC load, okay, or home load, and also the solar PV output will be directly connected to the battery via this bidirectional converter. Okay, so the solar PV going to be used for charge the battery as well as single phase, that means AC load via single phase DC to AC conversion. Okay, during, so that may PV power mode, right? Whenever power available in the PV, so that going to be supplied to the battery as well as this AC load. So whenever the power is reducing, so what will happen, the first preference, right, that mean the solar PV is directly given to this load, the remaining power, excess power, will be used for charge the battery. Okay, so this is the concept uh, implemented here. And also you can see here, when the solar PV power goes to 0, what happen, the battery is going to be supply the power to the AC load via this single phase DC to AC conversion. Okay, so here we are not using any grid system. Okay, and also for example, if suppose there is no power in the PV, and then the SOC of the battery, startup charge of battery is very low, so then we can use generator set or AC input. Okay, so that going to be supply this AC load as well as to charge the battery. So for that we have this backup generation. So this is also known as backup generation generator, right? So we can use generator or AC input, right? AC input directly we can directly connect to the utility grid. Okay, in order to charge the battery and this to supply the power to the AC load. So this is during that mean during no power in the PV, and then a source of the battery is having low value, right? So then we can connect this one. So this is known as the operation of off-grid solar PV battery system. And so here you can see that this here we are using 48-volt battery. The rated capacity is 200 Ah. Okay, and then here we are using AC input, and so that could be, that means this act as a generator set and AC input. That means this AC input will be converted into DC. So by using this rectifier, and then it going to be filtered by using this LC filter, and then is going to be connected to the bidirectional converter. Okay, and also it going to be connected to the single phase inverter, and then after filtering it going to be drive this load or AC load. Okay, so this inverter going to be controlled by means of voltage control and current control. Okay, so here we are applying the voltage control concept, and then here we are applying the current control concept. So here we are measuring the voltage of the inverter and then going to convert it into dq form, and then here we are generating a reference q and d based upon the reference voltage, right? So here we are generating the d reference, q reference, so based upon the reference voltage. So here we are converting the inverter voltage in dq form. After that, here we are process via PA controller. Okay, so actual q, actual d is going to be compared with the q reference, d reference, and then going to be processed via PA controller, and then it will be generated the control signal in the form of d and q, and then it going to be converted into AB form. So here we are going to take only a quantity because of single phase, so that going to be that mean consider as a reference current. Okay, and then here we are measuring the inverter current, right? Inverter current, and then going to be combined with the reference current. Okay, and then is going to be processed via PA controller again, and then it will generate the modulating signal, so that going to be processed via pendulum generator. So this pendulum generator going to be control this inverter in order to convert this DC to AC. Okay, so this is working of single phase DC to AC conversion for the DAC load. So here we are going to I'm going to simulate this model. I'm going to explain the operation for different operating conditions. So initially I'm going to make the irradiation of the PV panel equal to 1000. Before that, here you can see that here we are using PSO MPPT and battery charger control concept. Okay, the PSO receive two input voltage and current, and then output will be duty cycle. So here we are measuring the source of the battery, the voltage of the battery. Okay, so based upon that, here we are comparing with the 100, and here we are comparing with the over voltage of the battery. So based upon this comparison, we are going to allow this duty cycle. Okay, if both condition is true, it going to allow this duty cycle, and then it will be processed by pendulum generator to control the bidirectional converter, or else it will be block this duty cycle, so the bidirectional converter has not operated, right? Okay, so this is a PSO based battery charger controller and MPPT controller. So first I'm going to explain this system with the solar power mode, right? So if PV having power, right, so we will see the results, right? So first I'm going to make irradiation equal to 1000. Okay, so here you can see that because of high irradiation, what will happen, right? The solar generating the power, right? So this voltage of PV is around 100 volt, PV current is around 16 amps, and then PV power we are here is around 1700, right? So here you can see that this is battery voltage, battery current, battery power. So here you can see the current is negative. So what's the meaning? That means solar is generating the excess power. Okay, so that's why battery in charging mode. Okay, and also here you can see that we are not using backup generator or AC input. So the voltage of rectifier and current will be zero. So the power is zero. So here you can see that the AC load, so this is AC load, and then you can AC load voltage. So here you can see that this is sinusoidal. Okay, so here the AC load is continuously getting the power from the PV. Okay, and excess power going to be charged the battery. So now I'm going to make the PV irradiation equal to 0. So we will check the result after that. Now I change this irradiation of PV is 0. So now we can see that the PV power is comes to 0 because irradiation goes to 0. Okay, so because of irradiation go to 0, so we are getting power will be 0. Okay, here you can see the power will be 0, and then you can see that now the battery comes, the battery current change from negative to positive, so that means it go for a discharging mode. And also you can see that the power that means discharging power is around 900 watts, right? And also you can see that the AC load continuously getting the supply from the battery. So because of absence of PV, now battery is supplying the power, okay, to the AC load. Okay, for example, now you consider SOC of the battery is very low. Okay, now I'm going to connect the generator set, right? So I'm going to include the generator set, and then we will see the result of the system. So now because of inclusion of the generator set, right, so now you can see that the rectifier, right, rectifier voltage is increased and current increased because of connection of generator set, right? Now this generator set supplying the power to the AC load, as well as here you can see that the whatever power generated from the rectifier, right, that directly drive this AC load. Okay, so it will be maintained constant, the main battery power is maintained constant. So now I'm going to increase the radiation of the system. So now you can see the variation of the system output. So because of increasing irradiation, so you can see that the PV power increased, so the power will be excess power will be charge the battery as well as supply the AC load. So here you can see that sharing of the generator set will be decreased to 500 watts. Okay, because of PV generating some power, right? So PV generating some power, that's why the power sharing of the generator set is reduced. Okay, if suppose again I am going to decrease the PV power, and then we will check the result. Now you can see that because of reduction PV, right, battery will be goes to ideal condition, and then we are getting power from the generator set, and then it will be supplied from the, that means it going to supply the power to the AC load. Okay, so this is the operation of off-grid solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.